In this tutorial, we're going to look at forecasting data into the future. So we have a fake restaurant here, and we have the values of people who've come in for dinner on days in the past. We're going to try to use those past observations as ways of predicting the future. We're going to create a few different forecasts here, and each one of these forecasts is going to get a little bit more refined and a little bit more accurate. We have a calculations sheet here where we're going to look at the differences per day, differences per month, and we're going to look at how accurate our predictions are. So if we go over to our sheet to get started here, it's always good to take a quick look around at what we have. We have a column that says day, and if we go down to the end here, how many days do we have? We have 1,559 rows of data, 1,558 days plus a title. And then we have a customer count for each one of these days in the past, and these are years from 2001 to 2005. Not full years, but we do have some half years in there. I've also created a column that says month number. Later on we're going to type in, or we're going to use a formula to find the month, the day of the month, the week, the day of the week, and that'll help us with some of our forecasts moving on later. We're going to look at the average number of people coming in the restaurant per day for dinner, and then we're going to look at a few different items here as well. Forecast 1 is going to be the first forecast that we build, and we're going to evaluate how well that forecast was at predicting the actual number of people coming in. We're going to use that to look back in time because we do have the customer count of those days. So we're going to build a prediction model. Then we're going to go back in time to see, was our prediction model accurate or not? Then once we've refined this model a little bit, we'll be able to use that for dates in the future. So forecasting the past really isn't that useful, but evaluating your model, refining it, and then using it to forecast into the future can be really, really impactful. So if you were trying to manage this restaurant, if you were staffing this restaurant, or just trying to get an idea of how many people are coming into this restaurant, if you had no idea and you were just kind of randomly guessing, probably not going to be the most efficient way to run things. Luckily, we do have the customer count of previous days, so a good place to start might just be to take the average. So in the calculations area here, I'm just going to type in average, or maybe average customer count, we'll call this. And this average customer count, we're just going to use a quick little formula here, equals the average of this column here. So we just took the average of the customer count for dinner. And the average was 401.1 people per day for dinner. Of course, some days are lower than that, some days are higher than that, but on average, 401 people came in. So in this average column, we're just going to reference that, equals calculations B1, but let's make sure that we lock this cell. We use the dollar signs to make it an absolute reference because we're going to predict this all the way down. Double click to copy that all the way down. Again, making sure that you have an absolute reference here, otherwise it's not going to copy the formula properly. So what are we saying here? We're saying that for this first forecast, so our model 1, forecast 1, all we're going to do is take that average over the history of this restaurant and assume that every day is the exact same and predict that 401 people are coming for dinner, whether it's New Year's Eve or a random Wednesday in September. We're going to have the same amount of people in the restaurant for dinner. Of course, that's not a very thoughtful forecast, but at least it's a start. So for this forecast number 1, we're just going to say forecast 1 just equals the average. And then we'll bring this all the way down. Then we have to identify, okay, was this good or not? So we're saying 401 people on day number 1, and there's 402 people. That's actually pretty close. 401 people for the second day, not so close anymore. 573 people actually came into the restaurant that day. 401 on the third day. There was actually 564. So in this column M, the absolute error, we're just going to take the difference. We're going to take L2 minus the actual count, so L2 minus C2. I've also put conditional formatting on here where we're going to use this second one here, this color scale. So red is a high number, and yellow, orange is the middle, and green is a low number. So here we're saying that we're under by 0.88 people. That's a very, very good prediction. I think we kind of got lucky on this first day, because if we copy this down just a little bit more, we can see that some days we were off by 171, or we were under by 171. Some days we were over by 126. So we're actually going to refine this formula a little bit. I'm just going to press undo to get us back to one cell here. We don't actually care if it's over or under. We just want to know how far off we were. So we're going to take the absolute value. We don't want, again, we don't care if we're under or over. We just want to see how good this model is at getting as close as possible to the real number. So we're going to use the absolute ABS function, wrap that around L2 minus C2, and now you can see that it's just a positive number. So all the numbers will be positive, and we're just comparing things in a better way. So I'm going to double click the little green box here to get us all the way to the bottom. And remember that with this conditional formatting that we've put on here, it's just a way of identifying visually how close we are. So a dark green is a good number. It's a good prediction, 0.88. Almost perfect. If we look at a red one, 255. We were off by 255 on that day. What else do we have here? 236, 250, 300. So there are some days off by 435 on February 14th. So you can see that although this model is a good start, there are some big errors. So how big are the errors? We're going to quantify that. So in the calculations sheet, in H2 here, I'm just going to type in forecast number 1, and we're going to look at a few things. We're going to look at the average error, so how far off we were per day on average. And to do that, we're just going to say equals the average of this column right here. So on average, we're off by 111 people per day. Better than not knowing anything, but not a great prediction. We're also going to look at the number of days where our prediction was off by more than 75. Sorry, off by 75 plus. And the number of days where we were off by 25 or more. And to do that, we're going to use an if, or a count if, to say count if this column, which is our range, press comma to go over to the criteria, and then in quotation marks, we're going to say greater than 75, and the quote and the bracket. And now we have, of these 1,559 days, on 1,012 of them, we were off by more than 75. Again, not a great prediction, but at least it's a good place to start. And we're going to see how many times we were off by that should say 25. How many times we were off by 25 or more. Whoops. I'm just going to copy this formula to make my life a little bit easier and just change this to a 25 rather than 75. So on 1,391 of our 1,559 days, we were off by more than 25. Again, not a great evaluation, but it's a good place to start. Going back to our data sheet now, if we kind of quickly look through this list here, see if we can find any patterns. So Friday, 573, Saturday, 564, Sunday, a drop, Monday, a drop. Friday high, Saturday high, Sunday low, Monday low, Tuesday low. Friday high, Saturday high. So we can see, and this is pretty expected, right? If you've ever worked in a restaurant, or if you've ever even booked a reservation at a restaurant, Fridays and Saturdays are generally busier than Sundays, Mondays, Tuesdays. So with this forecast number 1, just predicting the average, regardless of day, we can already see that's probably going to be an opportunity to improve this model. So for the forecast number 2, we're actually going to try to factor in the day of the week. We're going to say that Saturdays and Fridays, we're going to expect more people. Sundays, Mondays, we're going to expect fewer people. But how much fewer? Well, the first thing we have to do is create a little chart or table here to figure out what the averages are per day. So we want to see, we don't care about the time of year just yet. We just want to know on the day of week, how do the average number of customers coming in change, just based on day of week. And we don't have the day of week listed. We have the actual date, the full date. But we can get to day of week and see, I've created this day of week column here. We can get to that just by typing in a really simple formula called weekday of B2. So the serial number, or the date number, is the date that we're looking at. And then if I press comma, it's asking me for another value, and that's the option or the return type. We're going to use number 2, which just means that the week starts on a Monday. So number 1 is Monday, number 2 is Tuesday, number 3 is Wednesday, and so on. 7 is Sunday. These will all work, but just to keep things consistent, we're going to say that Monday is the start of a new week. Then we can close the bracket, and there we go. So for Thursday is number 4. If I double click this all the way down, we can see that Monday is number 1, Tuesday is number 2, Wednesday is number 3, and so on, all the way down. Now we're going to create a little table that shows us what is the impact, the actual impact of every weekday, and how does that change the average count. So are Saturdays on average actually more busy than Sundays on average? So to do this, we're just going to insert a pivot table, and with this pivot table, we're going to use day of week number as our rows. Oops, day of week number. Day of week number as our rows. There we go. And customer count for dinner as our values. We don't want the sum though. We want the average. Let's see if we have a difference here. We do. Okay, so 284, 300, 328. We can see that there are definitely differences depending on the day of week. We're actually going to do a little bit more work with this. So I'm just going to copy this chart here, and then in my calculations sheet, I'm going to paste this in here. Oops, I'm going to paste special actually. I just want the values. So the row labels, we're going to call this days of week. We don't need the total right now. We already have that average and the average customer count for dinner. Now that we know the average customer count for dinner, we want to see the difference. So the difference from average. We know that the average is 401. So day number 1, which is a Monday, we're just going to take the average, or sorry, we're going to take the actual count minus the average. So here we're saying that we are under by 116 people per day on average. I'm going to lock this cell here because we want to compare against the average for all of these. And I've applied conditional formatting here. Color scales. Green is high, red is low. So here we can see that on the first day of the week, which in our case is Monday, we're under by 116. Second day of the week, under by 100. And then we have our Friday night over by 142, and our Saturday night over by 193. So this does confirm our suspicion there that the day of week does matter. So back to our data, we're going to try to factor this in. So for the day of week, right here, we're going to use a lookup, and we're going to look up this calculation that we just made. So we're going to go to the very top again, make sure that we have everything here. So what we're trying to figure out is, on this day, based on day of week, is it going to be higher than average or lower than average? So we can just say equals, and we'll use a VLOOKUP. What's the value that we're using to look up? We're using the day of the week. Press comma. What table are we referencing? We're using this table that we just created. So we're highlighting these 7 rows and these 3 columns. That's the array. The column index number is 1, 2, 3, because we want the difference from the average. So the column index is 3. And the range lookup is an exact match or false. So we can see that calculation right there. Here what we're saying is, because this is a Thursday, we're expecting, when we factor in the day of week, we're expecting that this is going to be under by 43.4 people. We're going to copy this all the way down, but before we do that, make sure that we lock this reference. So we've locked the reference to that table. And then we'll go all the way down, double click that. Friday, we're going to be over, we think we're going to be over by 142. Saturday, over by 193. Sunday, we're going to be under by 2, and so on all the way down. So now we're factoring in the day of week. So for this forecast, our model number 2 forecast is just going to be the average plus our calculation for day of the week. So forecast number 2, we're going to say now we're expecting 357 people on a Thursday. And then we can copy that all the way down. Our absolute error is the same thing. So in column M, we just had L2 minus C2. Here we're going to do N2 equals N2 minus the actual count. Again, we're using this as going back in time to see how well this model is working. And we're going to use the absolute value. Bring that all the way down, and we'll use conditional formatting here as well. with green being low and red being high. So now we can see that some of these higher values before, off by 192 in our first one, were much closer. Off by 255, down to 62, off by 170, down to 22. So it looks like, at least on the surface, this model is a little bit more accurate than the other one. But how much more accurate? I'm going to save myself a little bit of time here and just copy the formatting here. So for forecast 2, the average error wasn't of column M, it was of column O. We're off by only 52. So right off the bat, just by factoring day of week, our average error is much, much lower. We want to get that as close to 0 as possible. Going through column O again, the number of days where we were off by more than 75 was more than 1,000 before. Now only 346 days did we have really large errors. And off by 25, still more than 1,000 days that were off by 25, but better than what we were doing previously. I'm going to save this now. It's good to save every once in a while. So we're going to do the same kind of idea here with month as well. So maybe we look through the data and we say that summer is more busy than winter, or winter is more busy than summer. We don't really know the actual information just yet, but we are going to look at the month, the day of month, and the week number as well. So just like we did for day of week, there's a really simple formula here just to say month. So we're just going to take the month of our date, and it tells us that it's the 6th month, and that makes sense. This is June. You can copy that all the way down. For the day of month, there's another easy formula here. Just say day of the date, the 28th. There we go, 28th day. So this is the 6th month, 28th day, June 28th. Good, that makes sense. And then for the week number, equals week num of the date. So this is the 26th week of the year, this is the 27th week of the year, and so on, all the way up till the end of the year. So we have looked at our forecast number 2 that factored in the average and the day of the week. Now we're going to try adding in the month of the year. But first we have to figure out, is there a big difference between the different months? So now that we have each column with the month number, the day of month number, the week number, day of week number, we're going to continue building our next forecast. What we have to do now is look at the months and see if there is in fact a difference on average between each month. So to do that, just like we did for the day of the week, we're going to create a new pivot table, but this one based on month. So we're going to insert a new pivot table. We might have to go up and click this little refresh button. If you're getting an error that says blank, just hit this refresh button for the data. But what we're going to do, so I'll do that now. What we're going to do is click month number for rows. It should show rows number 1 through 12 for each one of the months. But again, if you're getting an error that just says blank and it doesn't give you these rows, just click the refresh button to make sure that you have the right data there. So then we're going to, now that we have the rows, we're going to look at customer count for dinner. And it's the average, not the sum. So on average, month number 1 has 421 people. Month number 9 only has 365. So we can see there are some differences depending on the month. Just like we did with the day of the week, we're going to copy this. And then in our calculations sheet, I'm just going to paste the values. And we'll call this months. We'll call this, average customer count. That works. And just double checking that our average per month is the same, 401. In the calculations, we're going to find the difference from the average. So the average per day in each month is just like we have up here, C6, or in this case, C17, equals C17 minus our daily average here. And we're going to lock this B1 cell because we're going to copy this all the way down. So now we have some months. The 9th month is about 35 people per day under, and the 12th month is 62 people per day over on average. So we can see that there are definitely some differences between the months. Going back to our data sheet, we're going to factor in the average per day, the weekday difference, and the monthly difference in order to build our third forecast model. And to do that, we're just going to add these 3 items up. Or sorry, no, first we have to actually put in the average per month. So just like we did with the day of week, where we used a VLOOKUP to reference that new table we made, in the month, we're going to use a VLOOKUP based on the month number. We're going to reference our month average, the column index 1, 2, 3. We're looking for the returning the third average, so we want the third column, the difference from the average, and it's false for an exact match. I think I have an extra comma in there. Third column, false. And now we can say that June is about 10 people fewer per day on average. I'm going to lock this reference to make sure that we're keeping it within this this array, this table the entire time, and then we'll copy this all the way down. So we can see June 10 under, July 18 under, August 12 under, September 35 under, get to December, and it's 62 over on average per day. So for forecast number 3, we're just going to take our average plus the difference for day of week plus the difference for the month. So we're going to say that on this first day, because it's a Thursday, it's going to be 43 days less than the average, and because it's in June, it's going to be 10 days less than the average. So a Thursday in June is going to be about 53, 54 people fewer than average in general. We'll copy this all the way down, and then we'll get our absolute error, which just like this one here is our value minus C2. So equals our forecast minus C2. There we go. And we want the absolute value of this. How close did we come to being accurate or bang on? And we'll take this all the way down. We're also going to put conditional formatting on here so we can see that a red number is high and a green number closer to 0, the better. So let's see quickly, were there any big numbers? So this one was 128, went down to 92, 95 went down to 59, but there were a couple that actually didn't perform as well. like this one here. In the calculations, we're going to see overall how well we did for forecast number 3. So we'll change this to forecast 3, and looking at column Q. So rather than O, we're going to do Q. Not a huge difference, not a huge improvement from our weekday, but now having weekday and month, we're off by less than 50 on average per day, reduced the number of really large errors, and had a slight improvement on the number of small errors as well. So we've looked at the day per week, we've looked at the month per year. What else could there be? I'm going to save this now, just to make sure that we're saving as we go on here. And I'm going to, in this worst predictions sheet here, I'm actually just going to copy everything from our data, Control C, and then paste it into here. And we're only going to look at, going to get rid of all of the, actually I'm just going to hide these columns. And again, this is a copy of our regular data. We don't want to be working on the regular data sheet right now. I've just copied everything into the worst predictions sheet. I'm going to hide these columns. And we're going to look at the worst predicting days. So which days were we off by the most? You can just go like this. So we're going to sort by descending, and we're going to look at the days where we were off by the most. Let's see if there's any patterns here. October 16th, doesn't sound like a very important day. May 12th, maybe that was around Mother's Day, second Sunday in May, could be. February 14th, Valentine's Day. December 31st, New Year's Eve. February 14th, Valentine's Day. Another Valentine's Day, another Valentine's Day. So it looks like there are a few different holidays in here. Close. The final thing we're going to do in this project is looking at how we can use this to predict future dates. So we're going to forecast into the future. So far now we've only done a forecast of past events, which, although it was helpful in developing the models and developing what we're factoring in and what we're not factoring in the real world, it's really not that useful to factor in things that have already happened. We want to look into the future to understand, how many people are we likely to expect at this restaurant next week or the week after or a month from now. So to do that, we're going to create a new sheet called Future Predictions. And we're going to copy the top 2 rows here. So Control C or Command C, and then we're going to paste them in here. So let's make sure that we have the month, the day, everything is working here. If we open up this date a little bit, so we're going to try to use this model. We're going to use the forecast number 4, which is the most accurate model that we built. We're going to try to predict dates in the future. So we'll use 2021. Maybe we'll start with June 1st of 2021. This is the 6th month, first day, 23rd week, and because it's a Tuesday, it's the second day of the week. So all of this stuff still does hold. The customer count, we actually don't know the customer count. That's what we're trying to predict. So we can delete this column because we don't have that information. This date hasn't happened yet, so we can't go back in time. 6th month, first day, 23rd week. We're only going to use this forecast number 4 column, so we can get rid of these other forecasts We can either hide them or delete them. I'm just going to hide them for now. And we don't know the absolute error because the date hasn't happened yet. So I'll hide that one as well. I'm going to copy these down for about 60 days, let's say 2 months of forecast. So now we can see, based on our model here, how many people we're going to expect for a day in the future. So on Tuesday, June 22nd, 2021, we're expecting 290 people, but for a Saturday in June, 584. For a Saturday in July, 575. So this helps us forecast into the future by building a model based on past events. So when you're done all this, you should have a calculations sheet that has the average customer count, has a table that we built looking at the differences from the average day depending on day of week, a table that looks at the differences on the average day depending on month of the year. We have one holiday that we've built in here. In the future, if you wanted to make this a little bit more in depth, you could look at multiple holidays, but we're only looking at Valentine's Day. That was the easiest one and the biggest difference. And then we looked at how well each one of these models did. So the forecast 1 model was off by quite a bit. As we refined these models and added a little bit more information to them, we improved the metrics overall. We have our future predictions, we have our worst predictions, we have our data sheet, which has the different forecasts that we made, and then we have a few pivot tables here as well. So when you're done this, you can save this Excel file and upload it to the course website.